Now we can do this now for all the pairs of movies to come up with this entire matrix D here. The diagonals doesn't matter, so just cross them out. The off diagonals are symmetric because the way we define it, DBC equals DCB. Okay, and indeed this is DBC or DCB, same thing, is minus 0.84 as we just calculated, and you simply follow the rest of the same structure for the rest of the entries. That's the end of the step 3. We have constructed similarity matrix. Now step 4 is to define a neighborhood. Let's say a neighborhood for any movie is just 2. Okay, so the top 2 movie with the absolute value Dij being the largest relative to movie J will be included in the neighborhood. So let's take an example. For example, let's say R hat 3D. We want to estimate user 3 rating movie D. Remember, user 3 rating movie D, we did not have that actual information. As we can see here, 3D is one of those that we were hiding from ourselves, so that now we can predict, see if we can get to 2. Okay, so we want to find out what is R hat 3D based on the neighborhood method. Well, first of all, there is the R hat 3D baseline predictor component, then there is the neighborhood prediction component. This happens to be 2.78. Now what is this? Since we decided the neighborhood consists of 2 movies, so for movie D, what are the top 2 similar or most dissimilar movies? This is for movie D, and we can see that movies A and B are most similar or dissimilar in the absolute Dij terms. Actually, both are very dissimilar. A and D are very dissimilar. Okay, so we have used so far the information about different people's taste on these movies. This is A up to E, right? A down to E, between movies D and A and B. And then we take that information, okay, the fact that A and D are very dissimilar by people's record, and B, D are also quite different by people's record, as a way to say that therefore A, B should be incorporated as we predict anyone's prediction liking or disliking movie D. So following our formula, we have minus 0.97 times the weighting. Well, the weighting turns out to be the prediction of the rating of user 3 on movie A. Okay, plus minus 0.73 times the rating of user 3 on movie B. And this happens to be 0.9 in the shifted domain, and this happens to be minus 0.19 in the shifted domain. So in particular, we see that the same user 3 whose taste on movie D we're trying to predict really liked movie A. But since A and D are very different kinds of movies, they're so dissimilar, that means she will very likely not like movie D. This is a big positive number, this is a big negative number. The overall impact is to make this R hat 3D n to be a very small number. And then we just normalize now by the absolute value of the Dij, which is 0.97 and 0.73. This therefore happens to be 2.35. In other words, the net effect of the neighborhood help is to reduce the prediction from 278 to 235. The actual answer is 2, and indeed in the baseline predictor it overshoot 2 by too much, very close to 3 stars, whereas with the help of neighborhood, knowing that A and B are very dissimilar from movie D, and user 3 kind of likes A and doesn't hate B too much, which actually tells us that she is going to really not like D a whole lot. with that information, we push 2.78 down to 2.35, which is indeed much closer to the actual ground truth 2. If you compute the squared error between 2 and 2.78, you see that's much bigger than that between 2 and 2.35.